Okay, so here we have a really good A-levels Core 2 paper about solving trigonometric equations. So we're going to go through this, and it's important to remember some of your details about trigs and trig circles. So let's begin. So this first part A, says solve the equation tangent of x plus 52 degrees equals tangent of 22 degrees. So while it may seem simple at first, you do want to use your substitutions here. So what we're going to say is tangent of u is equal to tangent of 22 degrees. We can see that if we have tangent equals tangent, then the respective degree measurements must equal each other. So u is equal to 22 degrees. Now, we don't immediately solve for x now and say that x is negative 30 degrees. We don't do that. What we have to think about is the circle itself. So, okay, bad placement for the circle. So let's put my circle over here. And so when I have this circle, really, you know, sort of shorthand. Actually, that's pretty good. So you have your four corners here, and you have to remember what these values are. So for those of you who have had me go through this before or have seen previous videos, you know that sine functions are really where the y values are similar. So if I have an angle and it's a sine angle, and let's say it's there, that means that y is equal to here. So where is the y value? Where is the sine going to be the same angle? Right here. And that's 180 degrees minus the same angle, because that will give me the same place. Well, for here, tangent, let's say that we have this angle here. Tangent is really sine over the cosine. So really what we want to do is we want to say, well, where are we dividing y over x? And whenever you divide two numbers and you want them to be the same value, you can't have them be opposites. So where is this angle opposite? For sine, well, that's where the y value is going to be negative. So that's down here and down here. However, if we look in quadrant 4, the x value stays positive. So we're dividing a negative by a positive, so this angle is actually going to be the opposite. So we're going to exclude quadrant 4. If we look at quadrant 2, this gives us a similar angle here. However, the y value is positive, yet the x value is negative because this is less than 0. So this will also give us a negative value there. So the only quadrant that will work with quadrant 1 will be quadrant 3 because we're dividing a negative y by a negative x. And even though these values are the same but, well, opposites, a negative divided by a negative will give us a positive, which will give us the same angle. So that means that we're going to be looking at this angle right here. And if you notice, that's going to be, if we call this 22 degrees, this is also going to be 22 degrees, but we're adding this on to this 180 degree mark. So we're going to say that in here, this is 180 degrees plus 22, which is 202 degrees. And so now I have two angles that I can use for my reference here. So I'm going to say that I'm going to have 22 degrees, which is right there. So 22 degrees. Then I'm going to go half of a circle around, which will give me 180 degrees plus 22, which will give me 202. And then I can go another full circle around, which is 22 plus 180 plus 180, which is give me 360 plus 22, which is 382. These are all values for u. However, we want to find the value for x, and this is where this x plus 52 comes into play. because u is equal to x plus 52. So in order to get to x, we need to subtract 52. So that's going to give us negative 30. That's going to give us 150. And that's going to give us 330. However, if we look at the domain, x must be between 0 and 360. So it actually can't be the first original one. So that means that x is equal to 150 degrees and 330 degrees. And that's that. Excuse me. So the important thing to remember here is what's actually going on. So we want to figure out this is an actual value given the angle. This tells us an exact position for the tangent, which is, again, the y value of the position divided by the x value of the position. And that's going to be the same exact position 180 degrees later, because we're dividing the complete opposite y by the complete opposite x, which is a negative by a negative, which gives us a positive. And then if we just keep spinning around, back and forth between these two positions, it's always going to be the same because it's spinning around in a circle. And that's why they limit it here, because if we went beyond, if we didn't have a specific domain, we would just keep going on and on and on for infinity. So that's the first part in solving the trigonometric equation there. So I'm going to clear some space here so we can look at number 2. Number 2, or sorry, part B, and this is the first part for B, we are going to look at this. We're going to say, show that 3 tangent of theta is equal to 8 over sine of theta, and show that this can be written like this. Well, if you notice here, we have a cosine and we have a cosine, but we don't have a tangent or a sine. So it would help us if we rearranged the sines first. Change the tangent to sine over cosine. So we're going to have 3 of sine of theta over cosine theta is equal to 8 over sine of theta. So I can just distribute this in, so I get 3 sine of theta over cosine of theta is equal to 8 over sine of theta. I can cross multiply here, so I get 3 sine squared theta is equal to 8 cosine theta. Well, the 8 cosine theta looks familiar because we have that as the middle term, but we have this sine squared of theta. That's actually where one of our identities comes into play. Remember, when we're talking about trig, we're talking about triangles and circles. If you have a circle, x squared plus y squared is equal to r squared, and this trig circle has a radius of 1. The unit circle has a radius of 1. So the x value is really cosine, so we get cosine squared of theta, plus the y value, which we said is always the sine squared value, is equal to 1. So that means that sine squared of theta is equal to 1 minus cosine squared theta. So we can use substitution here to say this is 3 times quantity 1 minus cosine squared theta is equal to 8 cosine of theta. If we use the distribution property here, 3 minus 3 cosine squared theta is equal to 8 cosine of theta. And if we move this all over to the right side of the equal sign, we'll get that 3 cosine squared theta plus 8 cosine of theta minus 3 is equal to 0, which is exactly what they wanted us to show. So just a couple of important things here. We have to remember the definition for tangent, and we use that for both the first part and the second part. So just be very, very mindful if you have a question like this, what exactly sine, cosine, tangent are. What do they actually mean? Because once you know what they mean and what they are, you can do more maneuvers like this. And this identity here, technically, I don't think really is an identity, and it's not on a whole lot of identity sheets. If you are taking the A-level Core 2 exam, it's actually not listed in your formula packet, but it's simple enough to memorize and to know, so definitely know that. All right, so that's part BI. And now if we look at part BII, we want to find the value of cosine theta that satisfies this equation. Okay. Well, if we look here, we have a squared, we have a power of 1, and we have a constant. So that's definitely a quadratic, and we have a 1, 2, 3 term. So it's quadratic trinomial, which means we can factorize it. While it looks intimidating at first, we can see that the leading coefficient here is a prime number. It's 3. So that means the only two factors are going to be 3 and 1. So we're going to have 3 cosine of theta, 1 cosine theta. And then the constant is also prime number, 3. So it only has 2 factors. So either in these two places, we're going to put either a 1 or a 3. But because this middle term is an 8, I'm going to say this is going to be a 3 and a 1. Because if I have 3 times 3, that will give me 9. If I make that positive, it will be positive 9. And if I subtract this, this will be a positive 8 for that middle term. So I get these two factors, so I can set them equal to 0. Oops, minus 1. So 3 cosine theta minus 1 equals 0, and cosine theta plus 3 equals 0. So I actually get two values here. Cosine of theta is equal to 1/3, and cosine theta is equal to negative 1/3. Here's where your brain is important, because cosine theta equals 1/3, that's fine, that's great, that's the answer. However, cosine theta equals negative 1/3. Remember what the cosine wave looks like. Ooh, not my best drawing. The peak is always at positive 1, and the minimum there is always at negative 1. And that's just for cosine. There's no coefficient here. There's nothing being added. This is not being transformed in any way. So this can't happen. You can't have cosine of theta equals negative 3. In fact, if you put in your calculator inverse cosine of negative 3, it's going to come up with an error message. So this is extraneous, and it's important to know that on the mark scheme for this particular exam question, you will lose marks if you have this incorrect answer. This is the one true answer. So make sure you only have cosine of theta is equal to 1/3. But if you, again, know a little bit about your trig stuff, hopefully that won't be too much of a stretch for you. All right, and finally, we have this. Solve this equation and give the values of x to the nearest degree. Important to note here, this is the same exact thing we solved for in part BI, except for instead of a theta, we now have a 2x. So before, when we had this, I probably shouldn't have erased that, cosine of theta is equal to 1/3. Now we're going to have cosine of theta, but the theta here is 2x. So we're going to have cosine of 2x is equal to 1/3. That means that 2x is equal to inverse cosine of 1/3. So when we find out what inverse cosine of 1/3 is, we get that 2x is equal to 70.528, we'll call it. Don't divide by 2 here. It's tempting. It is so tempting. But we don't want to do it. And the reason is because we still have to figure out about our positional placement. What other angles will give us this? So here I'm going to draw another version of my unit circle. And we're going to look at some of these angles here. So where is the, which x value gives me the cosine here? So if I have this 70.528 degree angle, that gives me this x value. And where is the x value going to be the same? Well, the x value is going to be the same down here. This angle, this reference angle, will be the exact same, except it's going to be below this line. This line right here is 360 degrees. So what we're going to have is we're also going to have that 2x is equal to 360 degrees minus the 70.528. and that will give us these two values here. When I simplify, I'm going to have that x is equal to 35 degrees and x is equal to 145 degrees. Those both fall within my domain. And I know there is some confusion out there about, well, do I add 180? Do I add 360? If the domain were, 720, then yes, we would take this point and we would add a whole nother 360 to it, and then we'd add a whole nother 360 to it. We'd find each point where this full rotation happens to this angle. To this point, we would do the same thing. So we would add 360 to this first value and add 360 to this to this second value. So 360, rotation, 360, add, and we keep going. But because we're just looking at this, we can see that if we add another 360 degrees to either of these values, we are going to be well outside of this range. So there's no need to do so. So just really think about this. These trigonometric equations, I know they're difficult, and this one was by no means easy. This was actually, I think, the last or the second to the last questions on a previous A-level exam, so you know it's difficult. But most of this question is just thinking about the basics. Do you understand what trigonometry is? Do you understand what's actually going on with these circles? And I know that some people like the cast diagrams here with the trig. I'm not really going to show you that because I think it's more important to understand what these angles actually are. This is your cosine angle. This is the x value. Where is the x value the same? Well, this is x value. This is the x-axis. So where does this x value stay the same? And this angle. And this is the same angle but below 360. If you think about this logically and you think about it knowing what these angles are asking you for and following the domain and understanding what a tangent is, if you think logically about all this, you cannot fail. So when you have questions like this, don't just prepare by doing a whole bunch of questions and solving and solving and solving. Actually look back at notes and look at other videos of what exactly a sine function is, what exactly a cosine function is. What is the unit circle? If you understand all of these, then all these difficult equations, they actually become very, very simple. All right, so if you have any questions, please leave a comment.